Hello everyone! In the new year we are going to transform this piece of crap into a studio diffuse light panel, and this is how it looks just now. I found it next to a trash can, thrown away. This is somewhat around 19, it's a 19-inch display, if I'm right. Yes, it is. And now let's try to disassemble it. So, before me showing you the end result, let's talk about some theory and how such a lamp should be designed and what we should keep in mind when we make such lightings. So, my idea came because I had everything laying around at home to build such a lamp, and it would be a shame not to use up my sleeping and lying resources. And also because if you make your own lamp, you can customize as much you want it easily without any kind of hassle. So that's why I choose to make one. If you compare the commercial ones to the DIY versions, well, small ones like half of this piece of paper, so the size of a A5 paper, they are quite cheap, but they are also limited in their output power in the form of light, and the cheap ones can go away just after a few hours of usage. But from the same price, at least where I live, you can make this kind of lamp. So the value over price ratio is more favorable for the DIY version, I think. So basically we have three main options to choose from. Well, the most safe and easy one is a 12, either 24 volt DC LED strip, which can be operated easily by a 12 volt power supply. You don't need any kind of extra or something specific hardware to light them up and to use them. The second option, oh, before I forgot, the only drawback of this solution is that you are going to have either a smaller, either a bigger power source, which converts the 22 volt AC mains to 12 volt DC or 24, depending on your LED strip. The next one is the so-called driverless. Actually, they are not driverless. Their driver is integrated on this piece of aluminum together with the LEDs. Probably this seems for many of the users the most convenient solution, since you don't need any kind of extra power or volt adapter to light them up. Well, the idea is true, but they are quite dangerous since they lack of any kind of protection or protective circuit on these PCBs, on these aluminum PCBs. And actually they are rated for quite a big power output. This small one, for example, for 50 watts, and also their efficiency is quite good, because I don't want to enter too much into the details, but on most of these LEDs you have 4 or 5 groups of LEDs connected in series, and each of these group is connected to its own constant current sink, and they work in a quite unusual way. So these LEDs are calculated and connected in series in such a way so as the mains rectified but unbuffered raw voltage as rises, so does each block of LEDs turn on. So the wasted power is only this small slice of all the input power, and this space is fed actively to the LEDs. So these are the main groups, for example in our case the 5 separate LED series. And on this board you can see here is the probably this or this one is the full bridge rectifier. After that is connected a very small capacitance, very small capacitor, and after that it comes directly fed to each group of LEDs. So imagine that this is a group, and out of this you have either 4 or 5 groups on this PCB. As I mentioned, they don't have any kind of protection or protective circuit. You have to be very careful not to leave them unattended, and if you don't interrupt the live wire, only the neutral one, the whole LED can be under the mains voltage, and in case of any kind of physical contact you can electrocute yourself quite easily. Also, these kind of LEDs need a huge and quite a beefy radiator to drive away the excessive heat generated by those LEDs and also the constant current sinks. Now let's go to the third group, the third category, which are these kind of so-called single LED, high power LED chips. The reason, since I'm presenting these kind of LEDs to a LED strip, is because you can also buy these kind of LED strips operated from the mains voltage, and they work at a similar principle like this one, only their physical form is different. And the reason why I'm presenting these two ones because they look quite similarly, and for unexperienced users maybe can be confusing and maybe put their life in danger. So in my opinion, it's a good idea to clarify the main differences between these kind of mains operated LEDs and these kind of DC operated big LEDs. So these kind of LEDs needed to be driven by current, and for this you need quite a large voltage, around 36 to 45 volts, in order to polarize all the diodes that are connected in series and maybe groups connected also in parallel. Well, the good thing about these ones, they're quite safe. You need a driver for them, but even for the unexperienced user, it is safe and does not put anybody's lives into danger. Also, to this type of LEDs, I would like to mention they need huge chunks of aluminium, either copper, heat sinks, because they heat up quite easily also. And that's for the main differences between the LEDs that you can use to make up these kind of lightnings. And I've noted some main differences, positive, plus, ups and downs, pros or cons between the two type of 12 or 24 volt operated LED strips and 2200 volt operated mains LED bars or diodes. So as you can see, these 12 volt ones are safe to operate, and without any kind of special qualifications you can work with them quite easily and quite cheaply, and does not cause any fire or electrocution hazards. So easy to hook up. They are usually sticky on one side. As you can see, I've just stuck one on my paper. So as you can see, they come with a sticky backside. And they have actually no kind of flickering if you're using a quality wall adapter. But as I mentioned many times before, you need a power wall adapter for them. Well, on the other hand, the mains operated LED bars, either diodes, are also easy to hook up. It's also easy to kill yourself with it, since if you take a look, you need to solder two wires on both of the pads. Well, the main problem with it, if you don't have a quality soldering iron, you can make quite bad and ugly solder joints, and with time those can come off and ta-da, you have a short circuit somewhere in your house. Well, the good about them, they don't really need power adapters because their power supply is laying here and there. They can cause also some kind of flickering. If you're sensible for this kind of flickering, you probably are going to face some kind of headaches. As you can see, the 5 or 4 group of LEDs light up one after each other. So, and this cycle repeats 100 times a second, so some kind of unseen flickering can cause headaches. Well, the other drawback of this kind of LED chips or bars or strips, it doesn't matter really, that in most of the cases you need extra additional heat sinks, while most 90% of LED 12 volt LED strips don't need any kind of thermal dissipation solutions. These ones need. And yep, that would be the ups and downs of using these kind of LEDs. Well, As you can see, the theoretical part, number 2, I'm going to talk about the mechanical assembly of a PC monitor. So, as you can see, you have a backplate. In my opinion, it wasn't a good idea to film the whole process and show you how I disassemble mine, because there are many kind of monitors and they are almost always different. So you can find similarities between them, but most of them, they are unique and different by each brand and by year. And as you can see, the main frame, the back plate, is represented like with these lines. On inside of that plate we have a white plastic paper, but it is completely light. No light gets through it. It only reflects light from the backlights. On top of that, you can find quite a solid and thick plexiglass, which helps to diffuse the light and also to make the whole mechanical structure more solid. And on top of them, there are different kind of diffusers, like these ones, as you can see, and something like these ones. Alright, and on top of them you can find the actual LCD panel, which is quite easy to break because it's made of thin glass and you can hurt yourself with it quite easily. And on the side of the display you can find the old either LED or neon strips, neon lights, and that's how basically the structure of a monitor looks like, or television. And in my case, I've put my LED bars just between that white paper and between the plexiglass, and I've put also one piece, only one sheet of this diffuser, and I hook up everything back together. Of course, the LCD, the glass part, I threw away because it was already broken and I had no driver electronics for it, so it had no use. It was useless. And that's about the theoretical part I wanted to say and to discuss. Now let's see how mine looks like. So this is the panel with the LED strips. Actually I have 8 strips in parallel. On the back side I've done some wire management, something very fast with some zip ties, and that's it. Don't forget to like or to subscribe if you enjoyed my video. If don't, then hit the dislike button and maybe see me or hear me next time. So Goodbye.